Today's lesson is on 2.3, scientific notation with negative powers of 10, and our goal is to convert small numbers to scientific notation and back again. It's very similar to yesterday's lesson in 2.2, only today we're going to be dealing with very small numbers, while yesterday we were dealing with very large numbers. Now the difference between yesterday and today is that positive exponents will equal or will give you a very large number, while negative exponents will equal a very small number. So let's go ahead and take a look at some examples of how this is going to look. For our first example, we have a human hair has a diameter of about 0.000025 meters. Convert this number to scientific notation. Now before I actually go ahead and show this example, I want to point out something to you with the way that I wrote out this number. If you'll notice right here, in between those two zeros, there's a small space written there. And I put that space there on purpose. When you're dealing with big numbers, we use commas after every three numbers. But when we're dealing with very large decimals, or I guess very small decimals, we need to leave a space after every third number. Okay, so we're not using commas when we're dealing with small numbers, but we are leaving a space still. When you are doing your work, when you are doing your homework or anything like that, I expect to see that space after every third number. Okay? So, just like with scientific notation, we want to go ahead, and I'm going to rewrite the number, leaving a little space after the third number. And now I need to ask myself still, where is my decimal now? Where do I want it to be? Right now, my decimal is right here. For some reason when I hit undo, it scrolls up. Anyway, right, I know where my decimal is, but I want my decimal to end up right here. Again, I want a single-digit number in front of the decimal. So the 2 would be the single-digit number that I want in front of my decimal. So I'm going to make ocean waves from where my decimal is now to where I want my decimal to be. Okay? So I moved my decimal from where it was to where I want it to be now. So now my number is going to be 2.5. Dealing with scientific notation, we're always going to have times 10. And now I count up my ocean waves. And I have 1, 2, 3, 4, 5 ocean waves. However, my exponent is not going to be 5, because 5 would indicate a very large number because it's positive. Because my decimal is very small, my exponent is going to be negative 5. So I have 2.5 times 10 to the 5th as my answer in scientific notation for the diameter of a human hair. But being that it's a word problem, I need to include my label using m to represent meters. Alright, let's take a look at another one. Our second example says the average diameter of an atom is about 0.0000003 centimeters. We want to write this number in scientific notation. So, I go ahead, I rewrite the number. This is the work that I'll expect to see when you do your homework. I expect you to write the number and then show the steps that you take in order to convert it into scientific notation. So right now my decimal place is after the first 0 on the left, and I want it to be behind the 3. I want a single digit number in front of the decimal, so I want it to be behind the 3. So I'm going to make ocean waves to get from where my decimal is now to where I want it to be. I want my decimal right there. So now my number is just going to be 3. There's not going to be any, let me try that again. My number is going to be 3. There's not going to be any decimal in this problem, but there's still an invisible decimal behind the 3, but it's just going to be 3 times 10. It's a small number, so I know my exponent is going to be negative, and then I count my ocean waves. And I have 8 ocean waves, so I have 3 times 10 to the negative 8. And centimeters. Okay? Now, we've taken a look at a couple of problems where we've taken a number in standard form, converted to scientific notation. Let's take a look at a couple examples where we do the opposite, where I give you a number in scientific notation, and you have to write it in standard form. For our third example, we have platelets are a component of blood that helps stop bleeding. Platelets have a diameter of about 2.33 times 10 to the negative 6th inches. We want to write this number in standard form. So in order to do this, we're going to start off by writing down 2.33, and we keep in mind our exponent. The exponent is the key factor here. We know that this is going to be a very small number. We know it's going to be a small number because we have a negative exponent. Now we have to ask ourselves, which way do we want to move our decimal in order to ensure that we have a very small number? Well, yesterday we were moving our decimal to the right in order to get very large numbers, so today we're going to be moving our decimal to the left in order to make us have very small numbers. So since our exponent is -6, I'm going to make 6 ocean waves going to the left. That does not mean I put in 6 zeros. It just means that I put in 6 ocean waves. Okay, so that's where my decimal ends up. Each of those empty ocean waves is going to get a 0 in it. And so for our answer, we're going to have 0.000, leave a little space, 002, leave a little space, 33. All right, and if you want to put a 0 in front of the decimal as well, that's fine, but you don't have to. I won't mark it wrong if you don't have that. All right, let's take a look at one more like this. All right, we want to convert 1.045 times 10 to the -3rd to standard notation. So I'm going to start again by writing the number out and then looking at my exponent for my key information. There's 2 pieces of information that identify from the exponent. First, I identify that it's negative, meaning I'm going to have a small number. Next, I identify that it's the number 3, so I'm going to have 3 ocean waves. So in order to make this a small number, I'm going to move my decimal to the left, and I'm going to move it to the left 3 place values. So the empty ocean waves, that's supposed to be a 0. Let's try that again. And I get my new number right there. So I'm going to rewrite it. 001, little space, 045. Okay, and again, put a 0 in front. That's fine. If you don't do it, that's fine as well. So we've looked at 2 examples where we convert scientific notation into standard form. We've looked at 2 examples where we convert standard form back into scientific notation. So now I'm going to give you 2 practice problems to work on, and I want you to be able to have those ready for us for bell work tomorrow. So here's your 2 practice problems. First, we want to convert 0.000078 to scientific notation. Then for example 6, we want to convert 9.9 times 10 to the -4th to standard form. Okay? So copy those problems down, work through them. Those are part of your notes grade. You must have those done. Okay? For 2.2, when I was checking in your notes, several of you did not write out the word problems. If you don't have these word problems written out, you need to go back and make sure that you do that now. Okay? So make sure that you have the word problems written out. Make sure everything that's written in this video is written on your sheet of paper. If you have any questions, make sure that you write those down, and we can discuss them in class the day after the video is watched.